Have you ever just stopped and wondered how we got here? From those clunky, old school computers to an AI that can whip up a poem, write code, or just chat with you in a way that feels incredibly human? Well, let's pull back the curtain and dive into the amazing story of how machines finally learn to talk. For so many of us, the first time using something like ChatGPT was exactly this, a truly jaw-dropping moment. It honestly felt like it came out of absolutely nowhere, right? It's no wonder people started calling 2023 the year of AI. All of a sudden, computers could understand us and talk back in a way that felt less like code and more like, well, magic. But here's the thing, it wasn't magic, and it sure wasn't an overnight success. What we're seeing today is the result of a journey that's been going on for over 70 years. It's a story packed with brilliant ideas, a whole lot of frustrating dead ends, and a few revolutionary breakthroughs that changed, well, everything. Okay, so to really get a handle on the AI we're all using today, we kind of have to look back at how the goalposts have been moving this whole time. The very definition of what cutting-edge AI even means has shifted dramatically over the years. What's so cool about this is you can actually see the frontier of AI research evolving. Back in the 90s, the ultimate challenge, the thing that proved a machine was smart, was mastering super complex games like chess. Then we moved into the 2000s and the big focus shifted to computer vision, teaching machines how to see and recognize things in the world. And that brings us right up to today, where the absolute cutting edge is natural language processing, or NLP. It's all about teaching machines to understand and use our most human skill of all, language. So let's rewind. Let's go all the way back to the beginning. Because the dream of a talking machine, it's not new at all. It actually started decades ago with one simple but really profound question. Way back in 1950, the genius mathematician Alan Turing came up with this idea. Think about it. Could a machine hold a conversation so convincingly that a person on the other end wouldn't know if they were talking to a human or a computer? For decades, that was the North Star. That was the ultimate goal for AI. And we had some really fascinating early attempts, like a program called ELIZA. It was designed to act like a psychotherapist. And you know what? It actually fooled a lot of people. But it wasn't understanding a single word. It was really just a clever illusion, using some smart pattern matching to find keywords and then fire back a pre-programmed response. A brilliant trick, for sure, but still just a trick. You see, the problem with programs like ELIZA was that they were built on rules that humans had to write by hand, and pretty soon, researchers just hit a massive brick wall. It turns out human language has, well, a gazillion rules and exceptions. They needed a completely new game plan. And this, right here, this was the plot twist. In the 80s and 90s, there was this huge shift. We went from the old way, where programmers would sit and painstakingly try to write a rule for every single grammatical situation, which, as you can imagine, was super brittle and broke easily. We moved to the new way. Instead of feeding computers rules, we started feeding them data. Massive amounts of it. Books, articles, the entire internet. We let the computers learn the statistical patterns of language all by themselves. And that changed everything. Okay, so progress. Computers could now learn from text. But there was still this one huge fundamental problem. Computers don't get words, they get numbers. So how in the world do you turn something as messy as language into pure math? Well, the answer was a genius breakthrough called word embeddings. Now, it sounds complicated, but the core idea is beautiful. Instead of seeing a word like cat as just a string of letters, the computer represents every single word as a unique list of numbers, a vector. This was the key that finally unlocked language for computers, turning it into something that could actually process mathematically. I love this analogy because it just makes so much sense. Picture a giant, multi-dimensional map of meaning. Word embeddings essentially give every single word its own unique coordinate on that map. And what happens is words with similar meanings, like happy and joyful, end up clustered together. And words that are opposites, they're way far apart. And this is the example that just blew everyone's minds back in 2013. Researchers working on a model called Word2Vec showed that you could literally do math with word meanings. You could take the number vector for king, subtract the vector for man, then add the vector for woman, and the closest word on that giant map was queen. It was incredible. It proved the model hadn't just memorized words, it had actually captured the relationships between them.
So we've got computers learning from data, and we have a way to turn words into math. The stage was set. But to get from there to the kind of AI we see in ChatGPT, one final, absolutely revolutionary piece of the puzzle had to fall into place.
So before 2017, the top models were something called recurrent neural networks, or RNNs. Think of them as reading a sentence one word at a time, in a line. It makes sense, but it's slow, and it has a terrible memory. By the time it gets to the end of a long paragraph, it's totally forgotten what was at the beginning. Then came the transformer architecture, and it just threw that old way out the window. It looks at all the words in a sentence at the exact same time, in parallel. This lets it see the full context and understand the relationship between every single word, no matter how far apart they are. It's a total game changer.
And of course, this didn't just appear out of thin air. You can see the progression here, like steps on a ladder. First, RNN showed us that processing sequences was possible, even if they struggled. Then came this critical idea called attention mechanisms, which helped models focus on the most important words. And finally, the transformer took that idea of attention and built an entire, massively powerful architecture around it. It was a rapid, step-by-step climb.
And that is the crucial link. The transformer architecture is the bedrock, the fundamental DNA of pretty much every modern language model you've heard of. Google's famous model BERT, the T stands for transformers, and OpenAI's GPT, yep, generative pre-trained transformer. The revolution was literally hiding in the name the whole time.
So we've gone on this whirlwind tour from the Turing test all the way to transformers. It's a really cool story, right? But why is it actually so important to understand this history? What's the real point?
Here's what I really hope you take away from all this. The AI we have today wasn't a single invention. It was a slow, steady evolution. Each one of these big breakthroughs, statistical learning, word embeddings, transformers, was created to solve a very specific problem that the last generation of tech just couldn't crack. And understanding why these innovations happened gives you a solid foundation. It gives you a framework for making sense of the crazy fast changes that are still coming our way.
You know, for decades, the entire goal was just to get machines to understand us. And now, we're pretty much there. So the big question we're left with isn't really about the technology anymore. It's about us. Now that we can finally, truly talk to our machines, what are the important conversations we all need to start having?